Alright, next section for the quadratic equations is how to solve quadratics. Now this is something that we've already done before back in, I think it was chapter 7, which was first semester. We called it like solving with branching, solving problems with x squared by branching. And so this is mostly just going to remind you of what we've done and reinforce that in the past, whereas sometimes when we took the square root of something we wrote it as a positive or negative decimal, in this section we're going to write it as a radical and leave it in terms of a radical, which is just a square root of some number. So there's lots of possibilities that can occur, and because sometimes you'll be taking the square root of a positive, sometimes you'll be taking the square root of a negative, sometimes you'll be taking the square root of values that lead to whole number answers, sometimes they'll lead to decimal answers. It's good to know the different types of numbers that can come out of these, so we're going to have a brief review of the number types as well. So there's lots of different categories that you can place numbers in. The natural numbers and the whole numbers, I'm sure you've learned about in elementary school. And I'm not saying they're not important, but I think that typically in upper level math classes, you don't necessarily care to identify a number as a natural number or a whole number. So I'm going to say that it's cool if you want to know them, but I'm not going to test you on them. Where we're going to start in terms of you have to be able to identify things is integers. So you need to know what an integer is, and being able to identify things or give examples of integers. So, and the integers are whole numbers, so no decimals, no fractions, but they do include negatives and 0. So for example, -3, -2, -1, 0, 1, 2, 3, and then etc. in both directions. So -117, +364,000. But you can't have any decimals and you can't have any fractions. Okay, rational numbers are all the integers and any number that can be expressed as a ratio of integers. Okay? So it's easy to remember this because rational starts with the word ratio, and the definition is it's a ratio of integers. So for example, 3/4 or -5/23. All these are ratios of integers. What about 0.5? Right now that's a decimal, but because it is equal to 1/2, which is a ratio of integers, then 0.5 is a rational number. Okay. Another example is 0.3 repeating. Even though it's repeating forever, you can write this as exactly 1/3, which is a ratio of numbers, and therefore 0.3 repeating is a rational number. Okay. Some examples of things that are irrational numbers or that don't work in this way are going to be given next. So if you're not a rational number, if you cannot be written as a ratio of integers, then you would be irrational, which means not rational. So this is all the numbers that cannot be expressed as a ratio of integers. So an example would be pi. So pi is 3.141592, etc. There's no cycling pattern for the digits of pi that would enable you to write it as a fraction. They go on and on forever, and they don't repeat in any logical pattern. So that's an irrational number. Another example is like, for example, the square root of 2. You could type that into your calculator, and it would give you a decimal equivalent. It's something like 1.414 ... and it goes on. And so if a decimal value repeats with a pattern, it's a rational number because it can be expressed as a ratio, because whatever that pattern is can be found out and then written as a fraction. If it's an infinite decimal that goes on forever with no pattern, then it's going to be irrational. Or if it's a special number like pi, or there's another one called e, which is 2.7 something ... goes on forever. So these numbers that go on forever are irrational. Okay. The last two things is to distinguish between real and imaginary. So real numbers are all the rational, irrational numbers, integers, natural numbers, whole numbers. All those are real numbers, and they represent everything that you've pretty much ever dealt with. All the numbers that you know of are real numbers. So you might be wondering, what the hell is an imaginary number? Well, an imaginary number is a non-real number. Okay, that's kind of a weird definition, but they come from the square root of a negative. So previously, you were taught that if you had, say, the square root of -9, you'd have to write no solution or it can't be done. But then mathematics has been extended by pretty smart people to actually say that even though technically this is not a real number, let's kind of make it into an imaginary number and see if we can still use it to help us solve math problems. And it turns out that actually imaginary numbers, which is the square root of negatives, can be very valuable in solving complicated math problems. So the way you would write this is the square root of 9 is 3, but because it was a negative 9, it's actually imaginary 3, and you do that by writing an I after the number. So the square root of anything is the number times I to represent that it's imaginary. But we won't be dealing with imaginary numbers really this year. I just want you to know what they are, so that when you try to take the square root, maybe when you're solving a quadratic, and you get in the square root of a negative, you can write down no real solution, but you know in your head what that means is, okay, the solution is actually imaginary. Okay? Now just a couple examples. This is again review of what you've already done. So solving a quadratic for x. So say you have 9 equals negative 7 plus x squared, and you want to solve for x. So the first thing you do is you have to get x by itself. So we'll say get the x squared part of the equation by itself, and then take the square root and branch for the plus or minus, and then solve for x. Okay, so those are our steps that we learned last semester. We're going to apply them here. To solve this guy, you have to add 7 to both sides, and then you get 16 equals x squared, and then you take the square root. Okay, whereas before I used to say you should branch into 2 places, here we just know it's going to be plus or minus, so you can just write x equals plus or minus 4. If it's the same number, you can write plus or minus. Let's do another example. 13 equals, I don't know, 2 times 4 plus x plus 3 squared. So this is starting to get a little bit complicated looking, but if we start from the outside and work our way in, it should be pretty easy. So divide both sides by 2, divide by 2, that's going to cancel. Here we're going to have 13 over 2, which is 6.5 equals 4 plus x plus 3 squared. Notice that when I divided by 2, I didn't divide the inside stuff by 2 because I had a 2 outside, and 2 over 2 cancels, so nothing goes into the inside. Okay, now I subtract 4, so these guys cancel, and I've got 6.5 equals x plus 3 squared. Okay, so now I'm going to take the square root and branch, but let me rewrite what I had. 6.5 equals x plus 3 squared. So I'm going to take the square root of both sides, and now I can write x plus 3 equals plus or minus. I'm just changing the side that they're on. X plus 3 is from here. The square root and the square cancel each other out. Here I've got plus or minus the square root of 6.5. Now, if this would have been a whole number, even if it's not a perfect square, like if it's a 9 or a 16 or a 25, you should actually take the square root and write down what the value is. If it's a non-perfect number though, like say it was a 17 or a 3 or a 10, you can leave it as square root of 3 or square root of 10 or square root of 17. But in this case, it's a square root of a decimal value, and typically you don't want to have a decimal inside of a square root, or likewise a decimal inside of a fraction, because if we take the square root, then it's still going to be a decimal value. So let me add 3 to both sides. Sorry, not add 3. To cancel out the 3, I need to subtract 3 from both sides. So the format of our answer is x equals negative 3 plus or minus the square root of 6.5. And technically that is the correct answer, but it might be nice, since it's already a decimal value here, to actually type in our calculator the square root of 6.5 and then do negative 3 plus that or negative 3 minus that. So let's just say convert to decimal, and I don't have a calculator on me right now, so I'm not going to actually type this in, but just be aware in your head that once you get it to this form, you can then actually take the square root of this decimal value and write two different answers, 1 and 2. Okay, so that's it for this section. Just reminding yourself of the different types of numbers and being able to categorize or label numbers as being real or imaginary, rational or irrational, and integers. And then practice solving your quadratic equations for x by working backwards, branching when you take the square root, etc.